In a ship's engine, the turbocharger is a welcome breath of fresh air. It's capable of significantly boosting the engine's performance. It does this by compressing almost 200 feet of air per second, then thrusting that air into the engine's combustion chamber. First, they make the turbine wheel. It's used to extract the exhaust gases. A long cutting tool known as a broach carves a tree-shaped pattern around the edge of a steel disc. The pine tree shapes are designed to interlock with the matching blades. Next, a computer-guided saw slices a brass alloy cylinder into small bearings. These bearings will support the turbine shaft. They make several bearings in a range of sizes and materials for different turbochargers. Computerized tools mill the surface of the axial bearing. They also drill holes to connect the turbine rotor and the casing. This is the completed bearing. A worker inserts one of the turbocharger's nickel alloy blades in a mold. He leaves the foot of the blade sticking out. He slides the mold directly under a spout, which dispenses a hot liquefied tin alloy. He fills the mold to the top. The tin alloy solidifies, encasing the blade just below the foot. This structure will fit into a clamping device in the grinding operation. An employee inserts the tin-encased blades into tensioning devices in the grinding machine. Inside the tensioning device, a clamping mechanism grips the blades. As coolant flows, a computerized grinder carves grooves in the feet. They're specially designed to engage with the tree pattern on the turbine disc. They pull the tin alloy blocks out of the machine. They break the tin alloy and remove the blade inside. Now it's ready to be connected to the turbine wheel. A worker slides the blade foot into place on the turbine disc. Then he bends a clip back halfway with pliers. He tightens the alignment with a clamp. He hammers the clamp down further until it lays flat against the blade foot and turbine wheel. This secures the blade to the wheel. He continues until the blades are in place. It takes 41 blades to complete the job. Next, computerized tools mill the aluminum compressor wheel and prepare it for cutting. The tools carve blades and grooves in the compressor. The design makes the compressor more aerodynamic. An aerodynamic compressor is important because it allows more air to reach the ship's engine. Here's the compressor wheel before and after the milling operation. Next, they run the compressor through a safety test. They lower it into a chamber and spin it a lot faster than it would normally operate. They confirm that the compressor can withstand a speed of 27,000 revolutions per minute without braking. Next, the compressor wheel receives an ultrasonic cleaning. High-frequency sound waves ripple through the water to scrub off any grease and contaminants. A worker uses a blower to start drying the compressor wheel. Then, he lowers it into a dryer to get rid of any residual moisture. When we return, this marine turbocharger will become seaworthy. Stay tuned. Turbochargers deliver fresh air to big ship engines. This enhances their combustion and adds to their mechanical might. Turbochargers help make these diesel engines among the most powerful in the world, allowing them to move gigantic vessels swiftly through the water. A technician shines an ultraviolet light onto the surface of the compressor wheel. This illuminates any fine cracks that could compromise its quality. If no cracks are found, they start assembling the rotor. The employee slides bearings onto the main shaft and turbine. He uses a crane to align the center hole of the compressor wheel with the shaft. He guides it into place and fits it to the bearing. Then he screws a cone-shaped cap onto the end. The turbine wheel is connected to one end of the shaft, and the compressor is connected to the other. The core parts of this turbocharger are now assembled. A technician locks the rotor in a balancing machine. When he activates the machine, the rotor starts spinning. Sensors detect the speed and the angular position of the rotor. They also check for any possible imbalances. The team uses this information to shave down the rotor and bring it into balance. Then, the final assembly of the turbocharger begins. The team screws the iron casing to the gas outlet. They attach 3 bearings to it. This insert is called the labyrinth cover. It will act as a seal for the turbine disc and shaft. The long bolts fit into holes in the bearing casing. He moves to the other side and secures the protruding bolts and nuts. He removes the compressor wheel temporarily to slide the shaft through the center bearing. The turbine wheel fits perfectly over the labyrinth cover. On the other side, he bolts the labyrinth disc to the casing. The labyrinth disc protects against hot turbine exhaust gas and prevents oil leakage. Then he reinstalls the compressor wheel. Meanwhile, an employee wraps rock wool insulation around the gas inlet casing. It's made of cast iron and built to withstand gases as hot as 900 degrees Fahrenheit. They cover the part with a heat-resistant fabric jacket. Then it's ready to be mounted to the gas outlet casing. Workers use a crane to move it into position. They align the holes in the part with the threads in the casing. Then they bolt it into place. They install a cast iron casing around the compressor wheel and secure it with numerous nuts and bolts. They hoist an insert part into place between the compressor wheel and the casing. Air will flow between the insert and the compressor before traveling to the engine for combustion. The turbocharger is now ready to be installed in a ship engine. This is done in the factory's assembly hall. Once in place, they fire up the engine and test its performance.